This is Troy Daniels, trainer here at SimpliPhi Power. Thanks for joining. We're going to go ahead and get started. I might have some more people trickle in, so I might repeat myself regarding a few things, but just a little bit of housekeeping. We have the Q&A at the top of your control bar there. So if you do have any questions throughout the presentation, go ahead and just type them in right there. Sorry there, get my audio a little better. A few other things. Just keep in mind this presentation is slated for an hour. Likely not going to take more than probably, I think, around 30 minutes. It's not the first time I've done this specific presentation, so we'll see how long it takes. So we should have plenty of time for questions. So again, any questions you have throughout the presentation, just type them right into that Q&A, and we'll be sure to circle around at the end to go through it all. All right. With that being said, let's jump right into it. Today's training is regarding the AmpliPhi battery. So this is specific to our AmpliPhi product. For those that might have been installing our products, you might have already started installing AmpliPhi, or maybe you are still using the Phi battery. They each kind of have their own reason and rhyme. We talk a lot about that in other trainings of why neither one necessarily is better than the other. They are really just, different batteries with different uses. So I would argue that neither is better than the other. They just have different applications. All right, with that, let's jump right in. We're going to start with a little bit of product overview, just looking at the AmpliPhi specs, and then we'll dive a lot deeper into it. So it's going to be a really rough overview with a lot more to come regarding the specifics of the battery. So kind of looking at the nameplate and just understanding the battery up front. Our AmpliPhi battery is a 3.8 kilowatt hour battery. So similar to the Phi battery in that sense, it's the same size, basically the same as far as dimensions and weight goes. So it actually fits existing wall brackets and ESS cabinets that we use with our Phi products. It only comes in 48 volts, so it does not come in 24. It holds the same UL standard, the UL 1973 and UL 9540A now, or excuse me, 40, no A, that's the test protocol, when it relates to system level as well. You will notice one big difference here on the actual upfront specs. Max discharge on the Phi battery, it is 480 amps, and for the AmpliPhi battery is 100 amps. So that actually comes with the 100 amp breaker as well. So it has a little bit higher surge capacity at that 10-minute mark. Flexible sizing, we'll talk a little bit more about that later, so I won't kind of dive too much, but for those that are aware of our sizing requirements, this one has a little bit more flexibility when it comes to smaller battery and larger inverter. I already mentioned the dimensions, and the biggest difference being that this battery has closed loop communications with the inverter and with the chargers in the system. This is true closed loop communications, meaning no external cards required for different inverters that it integrates with. We are kind of rolling through different inverters as we've rolled this product out. So currently we have comms set up with the Solarc and the SMA Sunny Islands. We have some others that are probably pretty close to being done, but we try not to jump on adding those to our list of approved inverter and chargers to communicate with until it is fully fleshed out and we know what's going on. Awesome. So kind of to jump back a little bit, I like this slide. It just kind of gives a good setting of the stage here on what a battery management system is, as that is really truly the biggest difference with the AmpliPhi versus the Phi battery is the BMS, the battery management system. So a battery management system is the brain of a deep cycle lithium battery that manages and protects the battery from functioning outside its safe operating parameters, monitoring various environmental and system-based conditions, calculating secondary data, and maintaining proper cell balancing. I would argue often that proper cell balancing is really, when it comes to lithium batteries, is one of the main reasons to have a battery management system. So basically, this is the main rhyme and reason why you'd have any battery management system. When you get into more advanced battery management systems, a lot more can be done, and various things like the safe operating parameters, auto-populated set points. We're going to jump through all of that and what this battery and what its BMS does. But the main purpose of a BMS is to protect the battery from damage and to ensure the battery has access to its full capacity. That's kind of the base level. Now, again, as we kind of move deeper into what a BMS can do in this industry, we're finding more and more that there's a lot more advantages than just that kind of base level protection and functionality. I want to talk about digital BMS. This is going to be really key for this battery specifically. We don't always talk about, if you look at one of our, trainings, like our BMS training where we go through, this is actually a slide from that training. You'll hear kind of the difference between analog and digital. For this presentation, we really just want to focus on digital in this case. So digital BMS have an user interface and communications typically. They're programmable. They may or may not be reprogrammable in the field, meaning you can actually change things field-wise. Take digital input and convert to electrical signals to take action. May or may not transmit data to external equipment. Oftentimes, I would say the majority of the time, they will. And batteries with a digital BMS may also have an analog BMS as a fail-safe, as is true for our AmpliPhi battery, to have both. All right, so let's actually look at the AmpliPhi key features and what it does as far as what it takes advantage of when it comes to these closed loop communications. Excuse me. High level protections, the first thing we'll look at. AmpliPhi not only communicates data and information to the system, so the inverter and the chargers, but it dictates a number of parameters in order to ensure the battery's safety. This is pretty key when looking at a true closed loop communication battery versus a non-true closed loop. So, you might see a lot of batteries that say, hey, we integrate with every single inverter, on the market, we've already got all of them through our runnings. A lot of the time, those are really focused only on communicating data and information and not actually working at how the battery can basically drive the system and control a lot of different parts of the system. So the data and information side of things is fairly easy, but to have true communications with the system, we have to be able to dictate a number of parameters and actually be able to make changes to the system directly from what I would call the brain of the system, which being the battery's BMS. So an example, for instance, low charge current versus higher than max charge current. So this is kind of something interesting our battery management system does. I think I'll go over it a little bit more, but we'll touch on it now. Basically, let's say you tried to set the set point on the inverter that you were paired with on our AmpliPhi battery higher than its allowable charge rate based on how many batteries you have. The BMS automatically knows that you've gone over the threshold and it will revert back to that safe setting. Now, if you try to go lower, it will accept that setting as it sees it as safe. So basically, it's a fail safe there where, again, the BMS in that battery is kind of dictating the system. And that's where it really plays a big role in high level protection. It also allows for flexible sizing when connecting to proper equipment. So we've talked a lot about sizing in my past trainings where we really harp on we want double the battery capacity versus the inverter. So if you have an 8 kilowatt inverter, you want a 16 kilowatt hour battery bank minimal to avoid over discharge. Typically over discharge more than overcharges. Most charging can be programmed properly. This battery does not necessarily have that restriction. So if we look deeper, we have these high level protections built in where it will basically say, hey, you are your inverter is too large for my battery bank. I will throttle down the output and make sure that it never discharges too much. This is kind of something that most inverter companies are implementing within their set points, but the battery management system can really take advantage of that. And we can rely on the BMS to allow for flexible sizing. So maybe we have two or three batteries on a 12 kilowatt, solar. And that's okay when it comes to the AmpliPhi, as long as all the comms are hooked up properly. So there's a lot more flexibility there. And the more inverters we add on to these, to our pairings, the more flexibility you'll see with different inverters as well, where, I know there's a lot of systems I see in different areas with maybe one battery in an outback system, things like that. So as we kind of move through pairing with different companies, that will be more and more available. Auto-populated set points. Believe it or not, it's a big one. It's a big ask. I see it a lot. I see installers asking for it a lot. This is the ability for the battery to basically dictate the set points, feed the inverter, feed the chargers, set points that it knows it wants. Again, I kind of talked about programmability, and we'll talk about there at the end. So I'll not get ahead of myself here, but settings are often able to be changed, but it will basically auto-populate most set points. So most set points program automatically when system is initially plugged in and turned on. That's all it takes. Sometimes, like with the solar, for instance, we'll go over programming later. It might require a simple checkbox just to say, this is a lithium battery. It needs to recognize that. It needs to recognize the battery management system, and it will accept that. And it will accept that the BMS will go ahead and dictate those set points automatically. This greatly cuts down on installation time. And there's a lot less chance for incorrect programming. I mean, it's something we struggle with in the field all the time. I mean, I understand when you're installing a number of different batteries all the time, it can be tricky to keep everything in your mind as far as what's what. And it's really nice that you don't even have to second guess it. It just makes sure that there's no incorrect programming. And it's really great for first-time installers to SimpliPhi Power products or for battery-based systems in general. So let's talk about settings and the how they can still be adjusted. And I kind of have talked on this twice already, but I'll explain it again one more time. And that's basically looking at max thresholds and minimum thresholds, and understand the battery knows when something is detrimental to itself, it will auto correct it. So again, if we're thinking about, let's say you're programming the charge rate double what the batteries can handle, the BMS will automatically catch that and say, no, you cannot do that. Revert back to the safe set point. Now, if you are charging, or you're changing the set point to be a less detrimental set point, so maybe you want to charge even less than the max threshold just to save the battery's maybe lifespan, or maybe you just don't need that much, it will accept that set point. So it knows when it's something outside of its threshold, and it knows when it's inside of its threshold. The same thing for maybe a minimum set point, like a low voltage set point along those lines. It knows when to take a set point and when it's going to be detrimental. So the battery can kind of, I guess the best way I can describe it is almost spell check a little bit. It can spell check the system to make sure that nothing is being programmed that it does not like. Let's also look at temperature control as a key feature. The AmpliPhi battery has an internal thermistor, accurate temperature readings within the battery and not ambient. So what do I mean by that? The temperature readings are coming from the cells. That's the location of the temperature reading. So what this allows for is you get a factor in things like heat produced by cells. The cells are really the main thing when you got to think about when you're thinking about temperature of a battery. That's where the damage could occur at low temperature charging or high temperature charging. So that's where it's key to be measuring. So we don't get incorrect measurements because we are measuring direct at that cell. We get to incorporate things like the heat being produced by the cells, the insulation of the batteries, and the respective enclosure that they are in. So again, maybe it's -2 degrees outside, and maybe it's 20 degrees inside your enclosure. And then maybe at the cells inside the battery, which is inside the enclosure, it is 40 degrees when it's charging. The battery now actually takes in that temperature. So you have less false negatives, as I almost want to call it, basically false flags that say, hey, this is the battery's not able to charge because the ambient temperature is so low. So that kind of plays a big factor here. As far as the charging temperature goes, 32 to 120 degrees Fahrenheit. I saw that question just come up, so I just want to nick that. That's the charging temperature. The batteries can go down to 0 degrees Fahrenheit as far as operating goes, and operating meaning discharge or standby. That's actually important when we look at the last piece here. With discharge is allowed to continue based on operating temperature, which is lower than charging temperature, as long as charging does not occur. That logic is built into the battery, meaning if, let's say it's really cold outside, maybe it's 20 degrees, too low for the battery to charge, but not too low for the battery to discharge. The battery is actually, the BMS allows the battery to continue to discharge as long as charging does not try to take place. So this can be really kind of key in a situation where it is really cold. You still have some juice left in the battery. You don't want to charge it, but you want to discharge it a little bit lower, even though the temperature is so cold. The battery automatically recognizes that and knows the difference between charge and discharge and the different temperature thresholds that it's allowed to do. Charging throttled based on temperature to avoid battery damage. So it does have the ability to basically throttle the charge rate based on the temperature, again, with that internal thermistor. And the battery will completely disconnect if battery temperature drops below lowest threshold. So what we just discussed being the thresholds there. So, while this is not necessarily the end all as far as like, hey, maybe we need some, we're in a really cold area where we need temperature compensation. Maybe we need like heating pads and things like that. This more just plays a really key role in maybe you've got a system that is going to go into an area where you're almost a little unsure of how the temperature is going to fluctuate. You think that it's pretty insulated. Maybe it's in a shed like the one here. Maybe it's warm enough where you think it will get through the winter and be okay, the internal temperature. This kind of ensures that it will never, it will disconnect itself to protect, but it won't hurt the battery. So it's kind of a safe bet when it comes to those kind of situations where you think you're probably okay. I see a hand raised. I can't actually unmute anybody during the training. So if you have any questions throughout, please, again, just type them into that Q&A. If you go up to that black control bar at the top, you'll see that Q&A section. We should have plenty of time at the end to go through everybody's questions. All right, so that's kind of a brief on temperature. Moving on, high accuracy readings and reporting. I think this is becoming more and more common. More and more people, definitely more and more homeowners are looking for the most accurate readings possible. And they'll notice a lot of the time when settings are a little, or maybe readings are a little bit off on state of charge, fuel gauge kind of situations like that. The AmpliPhi battery bank automatically reports information to the system for high accuracy monitoring. So this can include state of charge, again, its own state of charge being read from the battery and being reported to the system. Voltage of the batteries, charge and discharge, amps in and out. So we're seeing all of that data. We're a lot of the time we used to rely with like the kind of more basic non-comms batteries is we rely on what the system kind of can intel from itself. So maybe that's through a shunt or through, just reading its own multimeter voltage coming through. In this case, the battery is taking that data directly from itself and reporting it to the system. So like, let's say we're using the solar, that data is coming directly from the system. That can be super helpful. We definitely see a lot more accuracy that way. And we don't have to have so much second guessing and kind of checking. If you've taken some of my trainings regarding battery monitors, my stance on lithium batteries and battery monitors, they don't work great. This is the way to have high level accuracy readings and really ensure that what you're seeing is coming from the battery and it's known. Also, the battery bank will automatically adjust based on the bank size. So total capacity when new batteries are added, meaning let's say you do 2 batteries, commission them in, and then you add a 3rd battery, it automatically knows how to recalculate and say, hey, I've got a 3rd battery in the system. I know my new amp hour rating. I know my total capacity. That is all done automatically, meaning these battery management systems know how to communicate with each other on that level. All right. Moving on to installation. This is kind of where a lot of where we'll wrap up here, but we'll go through installation. Very brief overview. I just kind of want to talk a little bit about wiring and a little bit about programming. So I guess first and foremost is what's included with the battery. Obviously the battery itself, but also we want to look at, let me just make sure here. All right, just making sure I didn't get any comments about my audio or anything like that. I always like to double check. Okay, so what's included? Dust caps, battery to battery Cat5 cables. So these are the actual cables that run from battery to battery, and terminator plugs. We'll kind of discuss a little bit more what the dust caps and the terminators do, as well as the cables to each other. What's not included is the inverter cable. So the Cat5 cable from the inverter, or sorry, from the battery bank to the inverter. Why this is not included is we don't know the sizing there. We don't know what your sizing requirements are going to be from your battery bank to your inverter. So this is something that we would ask you get yourself as far as the Cat5 cabling goes. So we're going to look at this picture here. And we're going to talk a little bit through it, and then we're going to come back to this picture. So kind of just giving a really brief rundown. We're going to look through it. Again, it might not be perfect right away. This is the actual battery here, and this is the representation of the battery. So this bank of 4, we can see where the battery's been terminated, and then they're connected to each other using those Cat5. So in and out here, and then terminated again. These are dust caps. So we would have a dust cap here, a dust cap here, and a dust cap here. We only need one cable from one battery to the inverter. It doesn't actually matter which one, though we always recommend closest to. So basically you have a cable from one of these to the inverter. So this one would not have the dust cap. The dust caps are just there, as the name says, to keep dust out. So again, 3 RJ45 ports, 2 for battery chain connection in series, 1 for the inverter connection. So you can actually see here what this would represent is a battery cable coming in here, the terminator, because this is the last battery in the system, and this cable we would imagine going out to the inverter. You put the dust caps in the unused inverter ports, because again, you only need one. Terminator in unused battery to battery connection. So this would be on each end of the battery connections. So the first, kind of to give an example here, let's say the first battery would have a terminator, then it would have the cable to the next battery and a dust cap in that unused inverter. Every battery in that chain would have a cable coming in to one of the battery ports, a cable going out of one of the battery ports, and a dust cap because you're not using those inverter connections, and the last battery in the system. So maybe this is the closest to the inverter. Let's just imagine we would have cable coming from the last battery, a terminator as it's the end of the chain, and then another cable from that inverter or device port going to the inverter itself. You can actually see here, this is in the solar. So let's assume that this cable, I know they're not the same color, but if this cable is going to the inverter, this is where it would land in the system. We've got some great videos on our YouTube page that are out going through these different connections and actually showing one of our trainers, Matt Walker, plugging in different devices here where you can see all these connections. So again, this is just the rundown, the 3 ports, battery ports, and this would be, we could call it the inverter port. I believe it calls it device on the actual battery, but this is inverter. So we're just running the chain here, ending it on both sides. These are unused. This one goes to the inverter itself. Pretty straightforward. Definitely want to follow all of that. You definitely want to wire it all up before powering on the system. So programming on that side of things is made easy by the battery management system. As we talked about, the auto-populated set points allow for this ease of installation and help to mitigate misprogramming set points. The settings come directly from the battery management system. And as I mentioned, they do not require external cards or equipment. The battery management system has that data, has that comms capability built in. This is kind of a cool picture. You can see very rough wiring here where they're a little looped and everything, but it's Basically, you can see where these are connected, and then this yellow cable ran out to the actual inverter connection port. So as far as what programming is basically auto-populated as far as set points go, absorb, that will auto-populate 56. Typically, depending, the inverter might be a little different, but that's the good part. It will always know what inverter you're connected to. It should do that automatically. The end or end amps or end current, that'll auto-populate. Settings like float, if it's being used. EQ auto-populate, though it's not going to be used, and the system will automatically know that. The state of charge, the battery capacity will be automatically populated to the inverter. The max discharge and the max charge, and the temperature compensation. Those are all auto-populated set points. And then we go to non-auto-populated set points. So these are a bit interesting. Low battery cutout technically does not auto-populate. However, that's misleading. The low battery cutout now relies on state of charge, so it will never allow the battery to go below 0% state of charge. So that protection does automatically get programmed in. If you want to adjust to 20% as far as your low battery cutout, you want to discharge the batteries to 80% depth of discharge, you would just adjust that a little bit to 20%. But it will auto-populate as far as making sure that it never goes below its 0% state of charge. And it does that based on SOC, unlike voltage, because the voltage in SOC is being calculated within the battery itself. Anything to do with generator and grid charging, that's not going to be auto-populated. Obviously, that's something reflective of the system. So everyone has a little different depending on if they're using that or not. And as I mentioned, at least with the Solar, we're looking at the BMS lithium battery type. So 00 is the type. All we do is just type that in, make sure that the BMS lithium battery is checked so that the the system knows that a lithium battery is in place. Similar with the SMA, where we just need to let the battery, basically let the system know that the battery that's being used is a lithium battery with comms. All right, that kind of wraps up that side of things. I want to talk really briefly about the IQ program. Just a little plug here before we go into, it looks like we got quite a bit of Q&A, so I'll go through this and we'll jump right in. If you have any questions, now's a good time to type them into that Q&A. So IQ program, you've probably already heard me harping on this if you've taken any of my other trainings. This program is designed for people that are installing our batteries already. Not a requirement to install our batteries, but a huge benefit if you already are installing our batteries. So basically you will be included in the IQ Elite newsletter. You'll have a lot more visibility on our where to buy map, as you'll show up as a blip. So if our customers are looking around at where to buy in their area, they'll see you as a reputable installer that has done this program, that has got certified. And now we have rolled out our money in your pocket. IQ members are basically eligible for $250 per month on a photo contest we do every month with the IQ. I'll talk about that in a second, but also $25 cash back per battery installed that just comes with the IQ program. That's paid out quarterly, but we are basically going to be giving cash back to installers that are installing our battery and have signed up for this IQ program. The photo contest is a way to kind of add to that. Again, it just highlights projects and deployments through our marketing team. The winner each month gets $250 towards future SimpliPhi batteries, and photos of people and equipment are the best. We have rolling entries, so if you don't win this month, you might win next month still with the same picture. So definitely, if you've got some cool install photos, always send them through. We love seeing them more than anything, but it's a great way on top of this $25 per battery to actually win some cash. So you can really rack up the cash as far as what you're making back off this program. So why becomes qualified? Just show distinction over other installers with the IQ logo and branding. Join the program. You'll be shown as a trusted and knowledgeable installer, and there's incentives still coming out, but incentives already there with the cashback program. Takes about 10 minutes to apply for this program. Not much more. Follow that link. If you have any questions about the program, or you just want to kind of get an idea of how to get fast track through it, maybe you're you want to help out with the application and the tests and everything, training at SimpliPhiPower.com, email us there. We will absolutely help you get through that. So if you have any interest and you've installed our batteries already, reach out about the program. One of our trainers will reach back to you and get you all set up with that. All right, I'm going to jump right into questions. So if you have any further questions, go ahead. Now's a great time to type them in. What about closed loop with the Schneider 4048 inverters? I'm not super aware as far as where we're at with that on R&D. I know it's on the books, so I apologize. I don't have a ton more information there, but I know we're working on adding Schneider really, and really that would be all Schneider products, not just the 4048. Really, any of the Xantrex products or of the Xan bus equipped products will work. What is the safety temperature operating range of the batteries? So that was the question I answered off of. So again, 32 to 120 as far as charging temperature goes, that's Fahrenheit, and down to 0 as far as operating, which is discharge or standby. Do you offer cold weather application products? We do actually. So we have some heating pad options. Check out my training on cold weather mitigation, where we talk about some kind of out of the box ideas as well. There's a lot of different solutions out there. The heating pad's kind of the end all, where, hey, if you really need it, that's the best way to, you need that external component, that's where we go. But actually we do sell that direct through SimpliPhi. So through our distributors, obviously, but it is a product coming from us that we can offer. Dale, I see you're asking for a little bit more information. Feel free to shoot me an email at training@SimpliPhiPower.com. We'll help you out, get you any information you're looking for, or check out our training page. We've got a whole set of course catalogs there, as well as our YouTube channel that has tons of recordings for different trainings that we've done already. But definitely reach out if you're looking for more trainings, training@SimpliPhiPower.com, and we can help you out there. Like a regular battery, is it relevant to go positive to negative? Not sure what you get. I think so. That would be, we're talking about series. We don't put these batteries in series. I know it's a little confusing. We talk about putting the comms in series. These batteries are parallel only. So we do not want to put these batteries in series. They're all 48 already. We just want to parallel them onto a bus. Just simple wiring you would do on any other Phi products, basically. What brands of inverters are compatible with the SimpliPhi battery? So with the AmpliPhi, it's the SolarArc and the Sunny Island, the SMA Sunny Island. With the Phi batteries, really, we're pretty agnostic. You'll see a page on our website that says integration guides. Any of those that are listed on the integration guides, we've already gone through and validated. If you have an inverter or a charger that's not on there, just reach out to us and we can double check and make sure it works. But that would be with the Phi battery. Can you mix the older SimpliPhi battery with the AmpliPhi battery? You can, but I wouldn't do it. We're still making Phi batteries. We're not discontinuing that for any reason. So I would never mix AmpliPhi and Phis. You basically will have a battery that's a little bit more expensive that doesn't have comms capabilities. So, or I'm sorry, that really can't utilize its comms capabilities. So if you're putting new batteries into an old system that has Phi, I would recommend just putting new Phi in. Can these install in the Caribbean? Absolutely. Got tons of batteries installed over the Caribbean. I can't say for sure exactly, depending on your specific region, if we have batteries in that area. I will say I've spent a lot of time down in Puerto Rico with our distributors down there. We've got tons of batteries on the island and a lot of batteries in Haiti as well, but tons of all over the Caribbean, we have got batteries installed. CSA certification for Canadian installation. I'm actually not super aware of what that is. I know we have got the UL, I think you're talking about standard. We definitely have the UL with the CA, so the Canadian listing on it. But if that didn't cover your question, just reach out to us and we'll pass it off to the sales team that probably knows a little bit more about the CSA. Okay, already answered that with regarding inverter models. What is the amount of thermal gain during charging and discharging that will be captured by the battery bank? I don't have that specific data in front of me. Thermal gain captured or gain during charging and discharging to be captured. I don't have the specific numbers. I'm guessing that's probably something our engineering team would have to kind of chime in on with some pretty specific data. If my installation included an inverter without the closed loop communication protocol, did it work good like any other, just putting in the specs? Yeah, it does. So basically, do we have, can we use the AmpliPhi with a inverter that doesn't have comms? Yes, but again, I would just use the Phi battery, as it's a little cheaper, and you can just program in the settings like you would any other time. What is the cycle of your battery? I think maybe cycle life. At 80%, we say cycle life is 10,000 cycles. Our warranty is for 10 years, no matter the cycles. Are there any plans to make a 48-volt version of the P? I'm guessing you meant Phi. We do have a 48-volt version of that battery. I took the middle pick of the photo contest page. Sign up for the training. May I still be available for cash? Yeah, if you sign up. I don't know what the flyer, that's just what our marketing team made, but go ahead and reach out to us, just training at, and we'll get it all figured out. All right. Battery in Nigeria. What will it take to get your distributor in Nigeria? I think we've got some distributors in your area, so just shoot me an email, and we'll, again, a training at, and we'll pass you off to the sales team, where they can get you all hooked up with whoever is the distributor in that area. Oh, the Phi 1.4 was the question about the 48. Not as of now. I think we're going to stick with 24 and 12 volt for that. Are either allowed for install in New York City, Westchester, and Connecticut? Any incentives with utility? Not sure about the incentives. Definitely allowed to install in New York City. We've done a ton of projects recently, especially when it comes to 9540A requirements. So we've worked really closely with New York to actually be able to get through those different projects that can be a little trickier. Where is the link for the training sign up? So just go to our training page on our website, and you'll find either the training calendar for training signups, or if you're looking for the IQ program specifically, it's the installer qualification program link there. Your battery bank pictures showed connections between batteries of the bus. Is this practice approved with the Phi batteries as well, or just the AmpliPhi? We have been using separate cables for inverter. You can absolutely use terminal bus bars. Yeah, that is totally okay with any of our products, really. And what's the warranty on the battery? Last question, 10 years, unlimited cycles. How about Connecticut? I'm actually not 100% sure. I got to be honest with you. But we can look at it. I'm sure we have some. I would probably say if you want to reach out to Alt-E too, they're our biggest distributor, I would say, in that area. They have a ton of information and can kind of guide you through that and let you know what they're doing and what they're selling in that area. All right. One more question. I have 2-year-old batteries. Do you have a video on how to access battery health? Yeah, check out our YouTube page. There's a video regarding kind of maintenance there that kind of goes over what to check for. There's not a ton to be done, really. You can do a simple kind of capacity check and just make sure everything's working okay with voltage and things like that. But for the most part, the batteries are pretty hands-off for quite some time. All right, everybody. I really want to thank everybody for showing up. I appreciate it. And again, if you've got any questions, comments, anything like that, shoot us an email at training@simpliphipower.com. Thank you, everybody, and have a great day.